We are there. Okay, guys, welcome to a functional programming presentation. So I'm going to take you through your first sip of Lambda Kool-Aid. And so this is my functional primer before I start describing what functional programming is. So this is a quote I really like. It says, "Without deviation from the norm, progress is not possible." I think this kind of applies to functional programming because functional programming is definitely a break from how we normally program. I'm also going to define two words. I'm going to define easy, and I'm going to define simple. So easy means near at hand, or meaning familiar or close to what you already know. And easy tends to be relative, meaning if you know a lot about a certain subject, then a subject that's similar will be much easier to pick up. So, example, learning Java is easy if you already know C++, because Java and C++ share a lot of the same ideas. But if you're, somebody in Africa that doesn't even know English or hasn't had any mathematical skill or doesn't even know what a computer is or something like that, then Java will probably be pretty darn hard to pick up. So when you say something's easy, it's always very relative to where you are and what you already know. In contrast, there's simple, which basically comes down to being one thing. So it means of one fold, one task, one concept, one dimensional. The essence without any craft. This, however, is not actually relative, but it's objective. Although we sometimes use it in subjective senses. But it basically means that you've simplified it down till there's one thing. So that's what simple is. So functional programming is hard, not easy, generally. Because it's generally different than anything you've done before. The way you program in functional programming, a lot of ways, is extremely different than the way you program normally in imperative, object-oriented, similar styles. But you're tough enough, so you can do this. So let's get into it. So what is functional programming? Well, it's programming with mostly functions. There you go. Presentation over, right?
Sweet, we're done.
Yep, that's it. But actually, obviously, there's got to be a little bit more depth to this. So basically, it's programming with mostly pure functions. And by pure, I mean mathematical in a lot of ways. So what makes a pure function different than a normal function that we're used to in C++ or whatever language you prefer? So this is basically an example of a pure function. You may have seen similar kind of diagrams in maybe a calculus or some other class like that. But basically it has only really two or maybe even three parts, I guess you could say. But basically it has the input, the parameters that you put into it, right? It has the function, which does some sort of transformation to the input, but not actually modifying the input itself, and then it outputs it. And so basically that's what a pure function is. It's very simple. It's kind of one thing. It just takes the input, does something, and then generates an output. So talking about some things. So in normal programming, we have lots of visible, invisible. So these are visible inputs. What you have in the arguments and what you have in the return type. So does that make sense? So you can kind of see that, like in C++, this would be the argument list, and then this would be the return type. So there are lots of invisible outputs. So for instance, if you write the file system, that would be something that doesn't appear in the output down here. If you change variables somewhere outside the scope, that is something that doesn't appear in the return type. Database calls, nuclear missile launches, so on and so forth. There's lots of different invisible outputs, things that you don't see in the return type. There's also a lot of invisible inputs. So these are like somehow the function gets information from somewhere else that isn't the arguments. So these are like file system, user input, non-constant variables, database calls, you name it. So these are all things that this function got out from somewhere that wasn't right here. Does that make sense so far? Any questions? Yes?
What about a variable inside the function?
Variable inside the function isn't a problem because basically what in a functional programming language, in that as long as there's no observable side effects, so something doesn't happen because you run the function besides output coming out, then it's not a problem. Does that make sense? So local variables are perfectly fine. Like they don't mess with the input and output, right? It's just when you get variables outside of the function and you start modifying those, that's when you've got invisible output. Because it's not output if it doesn't come out, I guess you could say. Any other questions? Okay. Yes.
So are you describing mutable functions or what functions use this with invisible things?
Sorry, say that again?
What are you describing here?
Right now I'm trying to kind of show you the difference between, because this is the pure function, and then this is kind of like things that come in the function through sideways, not through the parameter list. And those would be things that are not pure functions. So I'm basically trying to contrast what we usually use as functions and what pure functions are. Does that make sense?
Yeah, right.
Okay. So, I mean, like a pure function would just be this, no invisible inputs or outputs coming out the sides. And then this would be like, you know, different functions. And I've got actually a list of different examples that I'm going to show you guys so we can kind of get a better feel for this. But as you can see, like if we start building our system without any sort of output and without any sort of like input from like the user or anything like that, then how can this possibly really be like useful? And the truth is, not everything can be pure. Eventually, we're going to have to reach outside of the function or outside of our program and touch something in the outside world, and that part of the program will be, to some degree, impure. But almost everything can be pure in the middle. So the main thing I want to drive home is when you build a functional programming system, you put the impurity along the outside edges of the system. But everything on the inside can pretty much be pure. So why do we want to build things with pure functions at all? Why don't we just keep on doing it the same way we've always done it? And the nice thing about pure functions is they don't have to worry about it property. Another thing I didn't actually mention, with these pure functions, when you pass in the same inputs, you always get the same outputs out. So same arguments in, always get the same arguments, or same output. And that becomes extremely predictable, whereas a lot of times when you like pass in the same thing to a certain function, its behavior will change over time because it'll be modifying some variable or it'll be doing something like that. So as I said that. So this is extremely reliable, which is really good. Some other benefits to pure functions, they're easier to test because you only have to test the inputs to make sure the right outputs are for the right inputs. They're easier to reason about, as I kind of mentioned. They're also easier to make concurrent because they don't reach outside of themselves, so you can run them in parallel very easily. They're also the ultimate in modularity because they only really depend on what you pass into them. They don't have any sort of external dependencies really at all, except for maybe functions that they use inside of them, but even that's kind of pretty loosely coupled. So these are like a list of things that you'd have to worry about if you're writing impure functions. So what happens if I call this function multiple times? You know, it may change over time. What other part of the system does this modify? What if I run these functions in a different order? What if I don't want it to side effect for a test? That's a big one. What does this class inherit from? That's just kind of a general problem that you could have. And when I put X, does Y come out? So even the normal problems you have with pure functions. The pure functions, you only have really one thing to worry about. Sorry.
So would a method for a class be impure if it's changing class variables?
Yes, it would be. And you can actually build, but there is a way around that. Basically, if you make a function that will create a new class or a new instance of a class without modifying the old one, then it's a pure function. Because you're basically passing in a data structure and then another data structure comes out. That makes sense. So you can build you can still use classes, but you can't modify the class directly. which is very different than what we're used to doing.
And that would be copying data. If it's a big class, it would be really efficient.
Potentially, but the thing about it is, and I don't have full time to go into it, but you can actually, because it doesn't change, you can copy over everything that does not change and just reference the old class. And so basically, you only need to have the one piece of information that's changed, and then you can reference the old one, which you can't do normally because that may change, but it doesn't change. So you can always reference back to the old one. So you can making copying is really cheap because you can always point to the exact same place in memory, and you don't have to worry about somebody modifying it. Like, you know, when you have tons of pointers and they're all pointing to the same piece of memory and how confusing that can be? That's not a problem if it's a constant. Like, you know, you can have global variables all the time, so long as they're constant. And I mean, you know, when has a constant pi got you in trouble? When has a constant variable that you can change get you in trouble? I mean, it's kind of like how it works. So that's a good question, though. I really appreciate that. So this is all you have to worry about with a pure function. Is like, if I put in x, does y come out the way I want it to? That's it. And so it simplifies things to a great degree whenever you change something from an impure function to a pure function. So let's see. Is it going to freeze? That'd be fun. Yes. Is there any other questions? Well, the computer decides what it wants to do. Okay, yeah, so we jumped ahead a little bit here. So I have basically two ways. We can either go through a bunch of examples of impure functions and pure functions, or I could go through a full example of refactoring some code into a pure functional style, or at least mostly. Which would you guys prefer? That makes sense between those two different options. So basically just going through a ton of different functions and showing what's pure and what's not, or showing how to refactor code.
Refactoring code seems interesting.
Yeah, let's do that. It's good.
That's
spend a lot of time on that.
That's going to give us more information than just comparing.
Yeah, that makes sense. It'll be more useful in my opinion. So we'll go over there to the Emacs. Spacemax.
Spacemax. Yeah.
Lots of fans out. Right, that's good. Probably have too many things open.
Oh, you have good grades.
Yeah.
Oh, thanks. Glad somebody. So.
Yeah.
Come on. Sorry. This thing. I cannot wait to replace Fedora right now. Okay. Did it? Did we do it? Is it done? Oh, this is fun. I apologize for any spelling errors or anything like that, as F and John have showed me. Usually you do not spell things right, and you write it only once and do not proof check it. So look at the general idea.
Like manager.
Yeah, exactly.
Yeah.
Manager
Yeah,
is
with
man.
one N. Programming with two M's.
I'm sorry.
Yeah, it's like I said, I went up to print them. It was just like, oh,
There's always typos. That's why I always
Really?
like to post it for you guys, so that you guys can fix them.
yeah.
It does not always work. All right. I can almost move my mouse. I think the best way to do this. Dang. This is a total failure.
Do you have it on your flash drive? No, I don't have Spacemax. Darn it.
Yeah, sorry.
You'd have to have Spacemax.
I don't know how it goes. Maybe we should have stuck with what we already had.
Maybe it's the fact that it has to output it to HDMI as well.
I almost think it would be faster to restart my computer.
Huh? We have time.
So let me think. Is there anything I can talk about that makes a lot of sense?
Oh. It did something.
All right. Yes, it is unresponsive, I'm sure. So I guess one thing I should mention is maybe some other benefits or some reasons you should learn functional programming. Carnegie Mellon actually made an interesting move. They actually removed object-oriented programming from their beginner curriculum and replaced it with functional programming. They made an object-oriented course that you could take later on as a more advanced course, but they said that that was a thing that you could learn in industry really easily, and that functional programming was far more useful. And that's like feedback they got from like Facebook and other companies like that. There was also a company that started, basically they don't write, they used to be a Ruby on Rails shop, but then they started writing things in Haskell and found that they had, that they basically don't write anything in Ruby anymore because it's so much, it causes so many less errors in Haskell. And there's another one that said, let's say, something interesting. That's slipped my mind. So let's try force quitting stuff and see if this goes. Another thing, if you've ever heard of WhatsApp, that's written in a functional programming language called Erlang. They actually, I don't remember how many engineers they have, but it's very few. It's like, I don't remember, it's like 100 engineers, and they have like, I don't know how many million users. And they basically kept that number that way because their code hasn't grown crazy amounts and stuff like that. Plus Erlang has some really interesting ways of handling concurrency and all that. All right. That's fine. Okay, we'll do that for now. I'm just gonna close things like crazy, see if that helps me. Just try to load and show my goods again because I want to do that.
Show my goods again.
Punk. Yeah. But also, let me see. What was some other things I was thinking?
Oh. Yeah.
Question.
Yes.
What are some applications of this? Where is it more useful than just regular code?
As far as, I mean, people would argue that it's more useful than when you have lots of information that you're trying to transform. So for instance, because the pure function basically works kind of like this, it's a transformation, right? So when you have things that you want in one form, right, and then you want them out in another form. So one thing that's actually very functional is compilers. So like if you take in a bunch of strings from the file, and then out comes the bytecode. Does it need to really do anything in the middle? Or you don't really care what's in the middle, right? Doesn't do anything. Basically, you just want this. I mean, maybe you get out like some type errors, which is another thing you can get out, But this could still be an output in the return, right? Another thing that's actually really functional is, do you ever know about the MVC model?
Model view controller.
Yeah, basically web applications. Let's think of a web application, right? So most of the time, these are actually written in object-oriented languages, which is kind of funny, but that comes in this way, right? Basically, this goes through your code, comes out this way, goes to the database, and then does something to it, and then it comes back as like HTML. So basically, if you break this up into two different functions, like this, then basically these can basically be pure functions. This is just a function that transforms the request into an action that does something on the database. Then this transforms that information it got from the database into the view or HTML. So this is a lot of ways, it's very much a function. So
would it be accurate to say essentially you have more functions but they're simpler, so they basically have less errors, you can spot errors easier?
Yeah, no, definitely. That's very, very much the case that I've found when I've programmed in functional programming languages. Also, I think the thing about them is, have you ever like looked at somebody else's code and then you realize that the function you're looking at, you need to understand the entire class to understand that function. And then you also have to understand all the classes that it inherits from. And then you also need to understand like some other classes that it needs to use in the API and like all this other stuff. I mean, like basically it becomes like this big spaghetti mess, right? Where you got all these dependencies everywhere. Whereas in a functional programming language, because it doesn't reach out and modify any state, you don't have to worry about it even modifying that state or anything like that. Basically, only you can look at a pure function all by itself. And you may have to look up a couple things like how the functions that it uses inside of it or something like that. But for the most part, you can understand it by just looking at that function. And you can work in isolation. Just you can even copy and paste that pure function into another file a lot of times and say, this I can just work on this, and that's it, you know. And I think that's super wonderful because if you've ever worked in a place where you have to understand 10 different design patterns to understand what's going on, and just to fix a small issue, that can be really beneficial. I think what else? Is there any other questions? I'm really liking these questions, so hopefully this is my computer's failures. I'm just gonna restart this. I'm sorry.
So I have another question.
Yes, please.
So what I got, this is more just a way of coding versus
Yes.
actual languages that,
Okay.
or there are actual languages that are kind of
Mhm.
focused on. They're set up so you have to program in functional programming to work.
Yes.
So there's languages that do that, but you can also just apply this to any language you know. It's just a way of structuring.
Oh yeah, absolutely. That's the nice thing about it is it's kind of like, I really hate applying it to object-oriented because it's not the same thing and they're not even really directly comparable. But in a lot of ways, like you can write functional code in any language. It's just, there's going to be a level of pain as to how hard and easy that is. In C++, it tends, and C especially, tends to be more and more difficult. Although if you use C++11, you have lambdas, and that helps a tremendous amount. But
Well, it's more and more that you have different languages that will support functional programming a whole lot better.
yeah,
And like Java set up super closely to an object-oriented paradigm, whereas you could do functional programming. It's a little different in the way that you would do it. It's a whole lot easier if you're going to say, for example, Lisp. You're going to use Lisp. Lisp is a functional programming language.
So it's based on, if you want to do functional programming, you probably want to pick a language that suits it better.
Yeah. Yeah, definitely. And I mean, like, I'm trying to think of even a good example, but like in Java, there's really no way to pass around functions. That's another big piece of functional programming that I haven't even touched on, is that functions are values and you can pass them as arguments to other functions. And that's super powerful and really useful. But like in Java, to write a pure function is really hard because they want you to write classes for everything that modify variables. But in like Haskell, you basically just do like your function name, like that, your arguments, x, y, whatever, equals, then you could do x plus y, and then that's a function. So that's like a one-liner, whereas in Java, you would have to make a class, you'd have to make a main public static void, args, all that kind of stuff. And then you would have to make a method, and then, then it would have some sort of function signature, name, this, make sure you get all of the commas, do that, and then curly bracket close, you return, x plus y, So it just kind of, the amount of ease that it gives you is quite dramatic as far as how hard it is to use functional programming. This might take too long. You guys want to just keep on doing, I apologize, I kind of totally skipped over the coding portion of it. We should have done that. But I can either try to go through some of this, some of the refactoring code, or you can just keep on doing questions.
I think refactoring would be.
Okay, let's hit it.
I think. I don't know if everyone
Let's
else.
do it.
Your laptop may die.
Yeah.
Yes, it will.
So
Where's
do I.
my backpack? I just had it.
It's right over here.
Sorry. Do you want to? Sorry. So I can go through this. Do you want to just like pull out this charger and plug it in? I appreciate that. Thank you.
Is Pascal a functional language?
No. Pascal is a very not functional language, but an interesting language nonetheless.
Haskell.
Haskell. Is it you're talking about Haskell or are you talking about Pascal? Pascal, yeah. No. That's definitely not. So okay. So manager says I want to do this application, make it fast. You're like, okay. So we start with a struct. So this is in C++. So you have, you have the Boolean and then you have the description. So pretty simple. So you start with the display to-dos. That's what we're going to do. You add the for loop that goes through the different to-dos that you want to display, and then it basically outputs a basic thing. So this is going to signify that it's done. This is going to signify that it's not done. And then you're just going to output the description next to it. And currently, it looks like they're all going to be on the same line, but that's just kind of fun. So what's the function signature of this thing? And basically, as you can see with the void over there, this is a function that doesn't have a proper output or return type, right? So this is an impure function. So yes, to use the void. So it's not really a pure function. So when you find an impure function, there's usually a pure function hidden inside of it. I apologize for that being truncated. Yeah, there we go, beautiful. So how do you test this with no changes to the code? How would you test this display method? Exactly, that's one way. But if you're trying to do an automated testing, which is usually what you want in a thing, I have no idea. I don't know if there's really a great way to do it besides maybe using string streams, which would be
String stream.
So let's find a much better way to do that. So, this is we're going to take this code and first we're going to clean it up a little bit. And so what we're going to first do is pull out just a single to-do item, right? Make that a single function. This still just counts it, so it's not a pure function. And now we have the old one, which just goes through and displays the to-dos, right? Kind of following? Okay, so it's still not pure. So let's refactor things. So I'm going to single out this function. We're going to work on this to make it a pure function. So the first thing we're going to do is make this output a string. And so instead, we've got this one variable right here, if you can kind of see my cursor. And this is going to store like the state of the current thing we're constructing. So if it's done, then do that. If it's not done, then do that. Return the done concatenated the strings together with the description, the return value. And ta-da, we've got a pure function now. Yay! So this one takes in a to-do and returns back a string, basically. But wait, this doesn't do the same thing anymore. We're just returning back a string, right? And so it will. So the first thing we're going to do is we're going to rename it so it's actually proper. It says to-do to string. So that's basically all it does. Next thing we're going to do is we're going to put all the dirty, nasty side effects in one single function. That's basically just going to call our pure function and then output it like that. So that gets pretty darn simple right there. And that's about as much. This is what you want your side effecting functions to look like. You just want them to do their side effects and do pretty much nothing else. So, come on. Yes, get my hands aligned. And then so basically we've got to refactor the second one as well. So here's the pure version of that. So basically it takes in a vector of to-dos and then kind of basically starts adding up the strings together. And so it's adding up the string and then it returns the final string. And so, and then down here is basically the this is how to display the entire list. And so you just call the function and output it. So now we go to testing. So I said that pure functions help things to be easier to test, right? And so let's see if that's true. So first I wrote this helper method that basically just takes in a Boolean, right? Then outputs if it's true or if it's not, and tells you whether the test passed. So let's try testing this thing. So we created a to-do, we put it through our pure function, right? So that's really where the heart of our logic is hidden in the pure function. And then we test to see if it's right. So that's the entire test right there. And that was 10 times easier than like trying to mock out standard out or something like that, right? This is another testing for the false case right down here. Sorry, is that too low? So this will basically make a false to do, then see if the X disappears here. And there you go. Yes.
So basically the way I see it is anything you want to do, break it up into like the smallest possible. And so you just have a whole bunch of tiny little functions that are all really kind of nice little blocks.
Yeah, that's definitely something you want to strive for. And some people argue that you're like, whoa, but now you have way more things, right? When you simplify things, simple means one thing, right? So the problem is most of our functions are multiple things. And really what we're doing is when you simplify things, generally you end up with more things because you're singling them out, right?
Could you or has somebody already built a library around this sort of thing?
What kind of library do you mean?
Well, like you have a loop function, you shove something in and it spits out a loop. Same sort of things. These are really, really tiny. So
yeah. No, there actually is a lot of functional programming. I basically did it the way I did it for simplicity's sake, right? But in a functional programming language, this would look even smaller because, for instance, if you know.
Oh, sorry. I was going to say that's why Lisp has so many parentheses. It's just because they're all functions. They're all functions. So you're putting Lisp. You're putting functions within functions within functions.
So yeah, like there is actually one. There's a function called map, which basically goes over every item of the list and then applies a function to each item of the list and then returns a new list. And so you could take my first one, which basically turns a to-do into a string, map over a list, say map to-do to string, and then you'd have a list. And then you could use a reduce, which basically takes a list of things and returns back a single value. And you could say, hey, reduce this by concatenating all these strings together with a new line in between them. And then you would have that. So basically you could eliminate a lot of the duplication here if you use first-class functions. So there's even more you can do to make this better, but in the basic sense, that's kind of where it's at. So I think that, I'm not sure, but I think that's actually about all I have. Yeah, pure so. So yeah, in pure, and that's I think the thing I like the most is like when I'm grading, because I'm a grader, a lot of people's C++ code, I'll find functions that are like 20, 30 lines long, maybe longer than that, maybe even 50. And that's when I'm starting to, like my functional brain starts to go crazy. And it's like, break them up into a ton of pure functions and it'll look so much cleaner and it'll be more usable. That's another thing actually that I really want to hit is like, the nice thing about, why does this make testing so much easier? And the reason is you're keeping inside of the values of the language. You're keeping everything in data structures that the language supports, right? When you see out something, it's gone. You can't test it, you don't know where it went. It's just like a black box, you just throw it out there. But when it's a string, you can manipulate it, right? It's part of the language. You can check things against it. You can do computations on it. So the nice thing about when you're keeping things pure is it stays in the language's syntax as long as possible and before it goes out. And so, like for instance, Haskell and a lot of other languages that are similar, ML family languages, they have exceptions that are basically first-class values that you pass around. And so the nice thing about that is you can handle the exception by doing different things with the value, but you always have the exception just like that you can like hold in your hand almost, versus if you use the exception in Java, it's just a syntactic thing that you can't control. You know, if somebody throws an exception, you can either catch it if you knew it was going to be there, but it's not really like a value, a hard value that you hold in language. Sorry, you had a question?
Well, no, actually, just a comment. It was just the idea that functional program focuses more on the cohesion.
Well, what do you mean?
Well, that it states that one function, one purpose, one.
Yeah, no,
one
it definitely
concept.
does. Yes, right.
And so it focuses heavily on that, which is why it's so. That's why the concept of it being simple comes into play, is because now your functions are no longer. They don't have five. You know, I understand because I'm a grader too. So it's like, you know, you have these functions that are huge with so many different purposes that are going inside of them.
Mhm.
When in reality, they make it so much simpler and a whole lot easier. Like easier as in you can see it and understand what's going on if you have one purpose.
Yeah, definitely. And the nice thing is you can actually have functions that have multiple purposes in a functional programming language. The nice thing about it is, like I said, they're like a transformation, right? They're like this. So when you get something that's getting a little too fat this way, there's only one. It's really easy. All you have to do is you go like this,
And cut it.
and then cut it in half, and now you have two transformations.
Yeah.
And so it's kind of like, that's way easier than trying to untangle a function's business logic from database code or something like that, right?
So how much of an impact does this have on memory? Like, okay, you've got a code,
Yeah.
you whatever the term is.
Copy it or whatever.
Yeah, you change it all pure and whatnot. Does it up the code size or decrease it?
It almost always decreases the amount of code that you write by a lot.
I think the thing with the cycle a lot of things was, because I know it makes a lot of stuff, but a lot of that stuff.
No, that's exactly true. Because the nice thing is, like I extremely trivial to reuse, right? Like mine, like I was even thinking about it. Like for instance, if you wanted to have a terminal to-do list, right? And you wanted to have to-do lists side by side like this, you know, with their name at the top like this. How would you do that with something with couts? You know, right? But if it's in a string, then you can take each one of these, concatenate the first ones, and then concatenate the second ones. And even my simple, stupid, to-do list function that just converts a to-do list to a string can still be reused for many things, even though it's highly focused on some sort of to-do list, So that's really where you get a lot of the thing. Because like, for instance, if you're in Java, I mean, how many getters and setters have you wrote in your life, right? Or even like in C++, like how many times have you wrote open file, close file, right? I mean, those are like, where in a functional programming language, you could say, oh, open the file, run this function, then when I'm done with my function, close the file.
Yeah.
Just that alone you could do, yes.
So with that function, could you have a parameter to be passed in a different sort of function? So it'll just open whatever that function is.
Yeah.
See, that would be useful.
It'd be highly useful.
It'd be very useful.
Exactly, yeah. So because like in a normal, when you can't pass in you can't pass in functions, like you have this block of code, right? And this is always the same, and this is always the same, right?
Yeah.
But say that the code in the middle here is not the same, like what you do with that file that you opened, right? And so the nice thing is when you can pass in this function, you can get rid of that duplication, even if it's in multiple places. But when you're in C++, like how would you do that? How would you remove the duplication? Because like it has to close the file, you have to open the file. And you may be able to trick around and use object-oriented stuff to maybe do that for you, but then you'd basically be making object functions that you're passing around, and then you'd basically be recreating functional programming. So it's highly powerful. I highly recommend anyone to learn it. If nothing else, it'll make you a better programmer because you'll see multiple solutions. Yes.
Good parameters and resources.
That's really good. One of the things it's hard because like there's a lot of great blog posts and stuff like that. I basically just read everything I could possibly get my hands on. But probably the thing that I recommend the most is there's a language called Elixir. Spelled ELIXR, like that, I believe. I think it's lang.org or something. You can Google it. And the nice thing about it, see if I can get to it. Yeah, there we go. Language is it's really just a cool language in general. But its getting started guide is really good. It takes you from very simple things down to much more things. It's really easy to get installed. The other thing I'll show you about it that I really like, if I can do that quickly, is is the nice thing about it is it has built-in documentation. So if you do list like this, then it'll give you nice formatted on the terminal documentation. So if you do hlist dot, like, let's see, what do you guys want to know about? Folder.
Just yeah, do folder.
L.
Existing.
So this
Fold L.
fold reduces a given list to the left with a function. It requires an accumulator.
.zip.
So it even gives you code examples down here,
Yeah.
as you can see. Well, you may not totally fully, huh?
What can you use Elixir for?
Right now, I mean, probably the biggest. I mean, you can really use it for anything. You can use it for terminal applications or other stuff like that. But probably where it shines the most is in web development. It's got a web development framework called Phoenix. Sorry, I should do it. Sorry. Which is really, it's basically a better
Phoenix.
copy of Rails.
Phoenix framework. It's below the GitHub.
Yeah, sorry.
It's all good.
I'm using Bing, so you just have to forgive it. So, and the nice thing about Elixir has some cool ideas. Basically, one of the things that it does is it has really easy concurrency, and it also has a lot of, it's built on the Erlang virtual machine, so it doesn't mean anything really, but like, it's just really cool. More or less the reason I like it is because it has really good documentation. It's got a build tool called Mix that's built into the language. It's just really easy to get started and learn about functional programming. And the nice thing is everything inside of the language is immutable, meaning you can't modify it directly in place. So it forces you to learn a little bit of that to get things done a little bit. But also it's some really cool things like pattern matching, all sorts of really cool stuff. I think it's a good starter language personally. The other language you can learn is JavaScript,
Yeah.
which is a functional programming language, or at least it's better as a functional programming language than anything else. People try to force it to be other things, but that's also a great one. I'm trying to think. Oh yeah, there's another really good one thing I'll plug before. Actually, I guess we still got a little bit of time. Yeah, we got a decent amount of time. Another one is I'm probably going to totally mess up the name of it. Nope. Sorry. And then here it is. In the kingdom of nouns. This is just a really good one. It's basically, hopefully there's not too many Java lovers out there, or else this will kind of hurt your feelings probably. But basically it's really interesting. It's basically talking about how the differences between thinking in a functional way and thinking in an object-oriented way, and the differences between those. I'd recommend to read. It's pretty short. Okay, I guess it's kind of long. Okay, it's kind of a long. I guess most of it is comments. So, but yeah, it's an interesting one. Let's see. What are some other great resources? I think. I mean, you could try learning Haskell. There's Learn You Haskell, which is pretty darn fun. For great good.
Yeah. There's a lot of companies
Is
that have Haskell.
What is it? What is Haskell?
That's an interesting question. That's actually one of the things I got into programming. Haskell. Let's just try Google on that. So now they've changed their site, so it's completely different. But it's an advanced, purely functional language, which is, well, that's actually quite overly simplified. But It's statically typed, which is really interesting. It has type inference, so you can, like, you don't have to actually write out the types if you don't want to, and then it'll just figure out what the types should be by flowing around the types through your code, which is pretty darn crazy when you experience it. It's like, you can write this type signature, or you can just write this, and you don't really see any types in there, but it's still statically typed. It just figures it out for you, which is pretty cool.
It's
Let's see. Oh yeah, the other thing is it's lazy as well, which is hard to explain. I can show it to you basically. Let's see if I can get to it real quick. Haskell is a harder one to learn, I will admit, especially if you want to do anything very useful in it, because you have to get past monads to basically do that. So I can't always recommend it. One of my favorite languages is OCaml, but again, a little bit harder for me to recommend just because it takes a little getting into. But for instance, I'll show you the laziness. So we do let x equal 1.10 or something like that. You can, then you do x and then it shows you that. But you can also do this. You do let x equal 1 ... and it's okay. And so if you try to print out x,
yeah, it's to infinity.
It'll basically go on forever.
Yeah.
Because it doesn't actually compute what I told it to compute until it needs to. You can also do this. You can take 100 from x, and then it will take the first 100 and compute them.
So it's just like math. It's a mathematical language.
I know, it's kind of crazy. Like you can even do like map. Let's do, how about times 2 to x. We'll do that we'll put that in y. How about that? And then if you do take 10 from y, then you'll get the same list, and it'll be doubled. Or you can take 1,000 from y, to get 1,000. So that's laziness for you. And that's only really possible because it's a functional language. But anyways, any other questions or any other things? Resources, I'm trying to think if there's any other great resources. I don't know. Personally, what I would do is just say, start with Elixir and maybe even JavaScript if you want. JavaScript's a harder one because there's a lot of code that's not written in a functional style in JavaScript, where everything in Elixir is written in a functional style. Oh yeah, join the Slack channel we have for BYUI.
You might want to post it right here.
Yeah, I
underneath.
can go get it. Sorry.
Here.
pitch.ly/BYUI-CS. It'll bring you to a page like this. And there's a functional programming channel inside of there. So if you ever have any questions, do ask. I'd always be happy to talk about functional programming. Probably get more than you want if you talk to me.
If you have any questions over classes, homework, or anything that you can't get a bit readily available,
yeah,
Slack for the school is really nice. There's a lot of alumni, a lot of seniors, juniors that are on here. And if you have questions, there's literally anything on there that you want to talk about.
Yeah, certainly. Please do join. Anyways, any last questions before I let you go from your long sitting? Good. How was it? You feel like it was somewhat easy to understand? This is like pretty much one of my first functional programming presentations. So.
I think where we took a procedural kind of aspect of it, and then we pulled it to a functional.
Yeah.
That helped me a lot because I've had the struggle of being like, okay, I get the concept of having different functions, but how, like for example, definitely with Lisp, how are we going to take it and how are we going to expand upon it with like with multiple functions within it? And it's like, well, it makes sense when you just have that function, it has one purpose, and you're just expounding upon it like, I hate to say it, like an object in a way, where you have an object and you kind of declare different methods in it.
Mm-hmm.
Whereas with functions, it's a function and it does what its purpose is.
Right. Yeah, definitely.
So it's starting to make a lot more sense to me.
Good. I'm glad. I always thought that example helped me a lot, is to basically take something real, transform it into a functional style. I would like that. Yeah, anything else? There's also code space it.
Yes. Code space at 5 o'clock. If you have any projects, anything that you want to work on, come.
Yeah.
Yeah, they're Tuesdays and Thursdays. Even though the poster says Friday, it's not Friday.
My bad.
It's Tuesdays and Thursdays at
I'm not
5.
very good at typos. Well, I
So-
am good at typos. Yeah, sorry about that. That's kind of sad, really, but so